Okay, guys, I think I'm live on YouTube. And we got some kind of feedback going on there as well. So we should be going live. How are we doing, guys? It's 5 o'clock. And yeah, I just thought I'd pop in here and just help you guys out with any kind of chemistry that you feel you need help with, basically. So essentially, open doors. And I'm still, there we go. There we go. I just need to mute myself because I can hear myself, which is not nice, to be honest with you. But there we go. So we should have a couple of people in here. If you've got any questions at all about the TT course, about A-level chemistry, whether you just started AS, so year 12 chemistry, so maybe you're probably doing atomic structure and this, that, and the other, or maybe you're in year 13. Who knows what you started with in year 13? It's a complete lottery, really. It completely depends on your teacher where you start. Some people start with organic, carrying on from where you left off in year 12, or some people start with something completely different. So in terms of inorganic chemistry, I know some people are starting with rates of reaction. Bit random in my mind, but there we go. Some people are doing transition metals and some periodicity and stuff like that. So yeah, I mean, literally open door policy now at 5 o'clock for the next, I don't know, half an hour. Basically just ask me any questions you want. All right. I mean, I can't necessarily help you with particular homework questions because there's no real means for you to kind of post those to me and get me to help you with them. But I can do that in the course. That's one of the best things about the course is you can take pics of your homework and we can help you with that. But essentially, if you're doing something at the moment, you're struggling with a bit of the like the theoretical side of things. So, if you're not sure about how orbitals work in atomic structure, maybe doing mass spec. So essentially, if you want me to explain something, I will. I've got the iPad ready. I can draw you a few diagrams, stuff like that. So yeah, Rich is with us as well in the chat, Rich Thompson. What's the most important thing to master in A-level chemistry? Well, that is the big question. Wouldn't we all like to know the answer to that? And I think there's probably more than one answer to that. I think probably mastering the bigger picture. All right, so chemistry and the calculations in chemistry and the explanations in chemistry are basically shrouded in basically the kind of circumstance, the question itself. So being able to take a step back from like an experimental question and say, right, well, I know what that student's trying to achieve. That's what they're doing. What's the big picture? And if you can see the big picture, it's much easier to see a path through in terms of what you need to say in terms of your answer or where you need to go in terms of your calcs. So that's the biggest thing to master. And we really focus on that in the web classes, right? Which I'm starting tonight. Official web classes of TT. Chemistry start tonight. Math started last night, and biology tomorrow. Andre, how do you convert between centimeters cubed and decimeter cubed, etc? You don't understand it when the unit is cubed. All right. Yeah, it absolutely works the same way, Andre. Okay, so if you want to convert, I don't know, say meters to centimeters, for example, all you have to do is multiply it by a factor of 10. Okay, so if it's I don't know, 2.2 meters, 2.2 meters times by 100, sorry, not a factor of 10. So 2.2 meters times by 100 to, because you go into smaller units, you end up with 220 centimeters. So if you've got 100 centimeters cubed of a liquid, okay, the factor difference between a centimeters cubed and a decimeter cubed is just a factor of 1,000. Okay, so if you've got something in centimeters cubed, you need to divide it by 1,000 to get it in decimeters cubed. Okay, so essentially think about it this way. The decimeter cubed is a bigger unit. Okay, so you're going to have fewer of them. So that's why you divide. Okay, so when you're going from centimeters up to decimeters up to meters cubed, okay, which you can get, you will be working in meters cubed. It's centimeters cubed times 1,000 to divide by 1,000 to get it in decimeters cubed, divide it by 1,000 again to get it in meters cubed. And of course, working down, you need to be multiplying by 1,000. So they're just factors of 1,000, okay? And sometimes you need to go from centimeters cubed to meters cubed when you do your ideal gas calculations. So I just take that centimeters cubed. So if you've got 25 centimeter cubed of a gas, what's that in meters cubed? Well, literally, I always put into the calculator 25 times 10 to the minus 6, okay? You put times 10 to the minus 6 on the end of it, you've got it in meters cubed. You put times 10 to the minus 3 on the end of it, you've got it in decimeters cubed. So that's how that works, okay? Next one up, Harvey, please explain esters and acyl chlorides. You missed today's lesson. Where were you? You should have been in your lesson today. Esters and acyl chlorides. I mean, what is it you want to know, Harvey? Okay, that's a big old topic. So specifically, what you need to know about esters and acyl chlorides. Do you want me to go over the structure, or what is it? Be a little specific, and I'll show you. Tips for acing A-level chemistry. How hard is it on a scale of 10? It really depends on what type of learner you are, what type of thinker you are. Some people really struggle with the memory side of things, so learning stuff in a parrot fashion. Organic chemistry. There's a lot to learn in organic chemistry. Some people really struggle with that, but ace the calculations. Some people really struggle with the calculations, but can remember all the different conversions in all organic chemistry really easily. So it really depends on what type of person you are. The trick is mastering it all, of course, isn't it? And I was just saying at the top of this that the trick to the most important thing in A-level chemistry when it comes to exam questions is seeing the bigger picture of the question, taking a step back, taking a look at the question as a whole, and then you really kind of stand more of a chance of being able to do that big calculation, or look at that conversion from start to finish. Okay, but it's about the details as well. So seeing the bigger picture, and then you can start applying the details on a scale of 1 to 10. I don't know. I think it's probably one of the harder A levels you can do out there for sure. Okay. As with any science and math subject, it's tough. Okay. Stealthy Wolf, do you know the grade boundary to get an A star compared to an A? Well, for an A star, okay, you need to get you need to be in the top echelon, don't you, of grade boundaries. Now, students every year, they're like, oh, what's the grade boundary for an A? What's the grade boundary for an A star? The thing is about grade boundaries, they're kind of mythical, okay? They move. So if you had a really hard exam, all right, and every student come out of that thinking it was really, really hard, did really rubbish in it, maybe the top mark that any student got in the entire country was 40 out of 100, okay? Let's say it was a really hard exam, top student got 40 out of 100. That means the exam board says, well, 60 of the marks were impossible. So that's where UMS comes in. That person who got 40 out of 100 is going to get the A star because that was the top grade. So don't ever worry about grade boundaries. Worry about the other people that are doing your exam that year, okay? You are in competition basically with all the other students in your cohort. So grade boundaries don't change much because, to be fair, the exam boards are pretty good at maintaining a standard of difficulty year on year in the exams. But the example I just gave you was an extreme one and will never happen. But grade boundaries have been fairly low with this new spec, just as the exam boards get to grips with it. But you do need to be in that top echelon, of course, for an A star. Some years it might be 85%, some years it might be 80% or even below that. So it really depends on the exam and the rest of your cohort. So Harvey, so the structures of acyl chlorides, mainly in the reactions of carboxylic acid with thionyl chloride. Okay, well, I'll tell you what, I'll go through the structures with you. Thionyl chloride is not something that we're going to need to spend a lot of time on, okay? But acyl chlorides and thionyl chlorides, kind of similar. So I'll talk about acyl chlorides with you. Right, okay, I'm just going to share my screen here now. Let's go iPhone, iPad via cable. So what we should be seeing in a second is my iPad. Okay, so that should pop up any second now. There we go. So acyl chlorides. Okay, so this is why it's called an acyl chloride, or the reason, I should say, why it's classed as a derivative of a carboxylic acid. So you've got yourself a carboxylic acid. Let's do ethanoic acid like so. Okay, standard carboxylic acid. Now we can convert that to an acyl chloride. Okay, now acyl chloride, the name's a little different, but the structure is very, very similar. So we can get from a carboxylic acid to an acyl chloride. Now it depends on your exam board, whether you need to know how to make that conversion or not. The conversion here, there's two ways, using SOCl2, okay, or you can use PCl5 or even PCl3. So that reaction there, okay, of a carboxylic acid to an acyl chloride, you can use any of those methods, but this has to be anhydrous, okay? So you can't have any water anywhere near it. And that's because these acyl chlorides, or acid chlorides, sometimes they're called, are really, really reactive. Okay, really, really reactive. Because as soon as this gets anywhere near water, it goes straight back to a carboxylic acid again. Okay, so you get an acyl chloride anywhere near water, you end up with back where you started, and that's no good to you. So why do these exist? Well, with esters, okay, we can make an ester using a carboxylic acid. I'm just going to draw the end of one here, like so, and of course, an alcohol. Okay, so that's how we make an ester. It's a dehydration reaction, okay, or condensation reaction, and we make that ester like so. But in order to make that ester with these two, like so, oh, come on, Rich, you know how to make an ester. Okay, like that. Then you need an acid catalyst. Okay, you really do need an acid catalyst because they're not naturally reactive with each other. You need to use a proton in order to kickstart that reaction to make an ester. However, with acyl chlorides, no such problem. You take your acyl chloride, like so, excuse my scruffy writing today, I don't know what's going on, and your OH, like that, and you end up with an ester, but this time you're not producing water as a byproduct like you do here, okay? It's still classed as a condensation reaction. What does anybody know what we actually produce when you take an acyl chloride and react it with an alcohol to form an ester? What was our byproduct here? What would it be? If it was water before, what is it now? Any ideas when those two molecules come together? Look at what I've just highlighted. What small molecule would we make as a part of this process? Any takers? Harvey? HCl, absolutely, yeah. So this Cl here and this hydrogen, they get eliminated. So it's still a condensation reaction. We get HCl as a byproduct, which is a downside to it, okay? Because HCl gas especially, really, really nasty stuff. Concentrated HCl, obviously an acid. So that's a downside of this process, okay? But it's really, really handy when it comes to producing esters. The reason is because this one is actually reversible. This hydrolyzes back to that very easily in the presence of an acid, okay? We can do acid hydrolysis with it. But this one, okay, it tends to be just a straightforward reaction and doesn't tend to get undone, if you like, okay? So that's how we make esters with acyl chlorides. The other big thing I will say about acyl chlorides is that they're used in the acylation of benzene. So Harvey, have you done anything with benzene yet and the electrophilic substitution in benzene? Because you use acyl chlorides for that, okay? So acyl chlorides will allow you to acylate a benzene ring, and I'll show you that very quickly, actually. So you've got your benzene ring, like so, okay? And let's say you want to add or acylate it, like so, okay? With this is ethanoyl chloride, okay? So cool, you've done the mechanism for it. So this is ethanoyl chloride. What we do is we react this with AlCl3, okay, which is our halogen carrier. You may have done that, and you end up with this. This is our electrophile in this case, okay? And once you've got this electrophile, okay, that's how we acylate a benzene ring. So in terms of the mechanism, you know the mechanism. What we'd end up with in this case is this, and that is how you end up acylating a benzene ring, okay? So that's that. Okay, Armin, how do you print off the PDFs for chemistry lessons for 6 o'clock today? So you click on the PDF, it should open it in a new window for you. All you need to do is right click and you can download or print it. Okay, so right click it and it'll give you the option to print or download or both, of course, and you're able to do it that way. Okay. Hey, no worries, Harvey. Well, you know, I'm here all night essentially, but unfortunately, not just on YouTube, okay? So at 6 o'clock, I'm going to be starting my first official live class with my year 12 students. We're doing atomic structure and stuff like that. In fact, I will show you what we're doing just while we're on the subject. So every week, I give the TT the TT students a PDF, okay? So they get it, a number of days before the live class. I tell them what we're going to be covering in the live class. And essentially, there's some links here. So what I'll say to students is, in the course, click this link. It'll take you to the topic that we're doing. Make sure you watch those videos. And then after you've watched those videos, there's some questions for you guys to have a go at. So I put in some multiple choice questions here. We've got, a number of different classic exam questions on that topic, okay? So what I'd like students to do, hey guys, A-level revision, TTBA, and RASEB, how are we doing? So essentially the idea is that you have a go at these questions beforehand, because you know what, the course is there in TT to teach you the content, okay? And there's exam questions in there for you guys where I've gone through them step by step on how to apply your knowledge and stuff like that. These lessons are really the icing on the cake when it comes to these topics, because I want you to have a go at the question. I want you to, maybe if you've got any mistakes, I want you to learn from those mistakes. We talk about exam technique, how to actually apply our knowledge to the answers, and obviously get the right key terms in there, and how to actually, present your calculations in the right way, make it easy for the examiners to give you the marks and stuff like that, okay? So I'm going to stop sharing now because I don't believe I need to do that anymore. So RASEB, how we use a live streamer for ultimate subscribers. Yeah, absolutely. Rich Thompson's in here helping me out in the chat. So yeah, so essentially, if you're an Ultimate Guide subscriber, or even just a Content Guide or Exam Guide subscriber, the live class registration page is in there in every single course. You go in there, you register for the live class, and then we manually accept you onto those courses. So just to make sure you are a TT subscriber, you got to make sure you use the same email address so we can find you in our course. We make sure you're an actual subscriber, and then we send you a link, and then you can use that link to access the live class, and that'll be live. It's not on YouTube, it's just in Zoom. It's a private closed class for TT subscribers only, okay? So we got a registration page. Underneath, as classes go on, they get recorded. We do a bit of editing magic. Our man Vlatko works his editing magic on them, and then a couple of days later they appear as a recording. So even if you can't make the live class, then you can always access the recording afterwards as well, which is awesome. So every Wednesday, okay, is chemistry. I'll go through the whole lot. Every Tuesday is maths, okay, between 6 and 8. So the first hour is year 12 topics. Second hour, 7 till 8, is year 13. Chemistry on a Wednesday, 6 till 7, year 12, 7 till 8, year 13. And then on a Thursday, biology with Rich. And again, 6 till 7, year 12, and then 7 till 8, year 13 stuff. And we've mapped out the entire course. And the best thing about these is mapped out the entire course in 20 online lessons. We're going to cover the entire spec by the end of March, okay, or the middle of March, really. So we'd have got you covered. Now, this is where you take your learning into your own hands, isn't it? Okay, because guaranteed you're not going to finish in school until after Easter. You want to give yourself a good amount of time to revise, and that's why we're going at hell for leather on these. So Dika and Armin. Printing out the questions for live classes. So you click on the PDF, you right click and you click print. If it only prints the first 3 pages. There are definitely more than 3 pages. I can't account for that. It's definitely the full PDF. You should be able to print all of them, okay? So I'm not sure what's going on there. Rick, you're having the same problem. Yeah, let's do that. Let's screen share and download the PDF, okay? So let me just bring up my my browser. Let's go into Teachable, shall we? Okay, I'll just get into the course, guys, and then I will show you. Okay, so content guide there. So you're just looking at my face at the moment. I know you're just looking at my face, but I just want to make sure I've got the course up before I share my screen. Okay, so let's do that one. Okay, guys, so you should just be seeing my my browser now. So what we need to do is you go into live class registration. And then this is this week's, okay? PDFs are out for the next few weeks, but I'll be doing that tomorrow, ready for next week. Obviously, this is where you register, and this is the PDF. So these two registration links are the same, basically, but the PDF for year 1 and year 2 is here. So you click on the PDF, pops up in a new window, and you should have all of the pages here. Okay, so why would it print out only the first 3 pages? Because there are 8 pages here. So right click, print, and you probably can't see the pop-up, but it's giving me a pop-up, and it says print 4 sheets of paper. I maybe assume that it's got something to do with your print settings. That's the only thing I can think of. Okay, so yeah, that's how you do it. Like I said, every week it's going to be in here. These are going to get crossed out as the weeks go on, and then underneath we're going to be having the live class recordings underneath here on the left hand side, AS and A level. Okay, so I just need to stop sharing so I can see your comments in here again. Okay, so yeah, maybe it was trying to do it double-sided or something like that. That's a very good point, Rich. Okay, so does anybody have any questions about the coupon? Because we have got a massive offer here at TT at the moment, and essentially you can get your first month free. All right, so try TT free, okay, all capital letters, and any ultimate guide course. So whether it's chemistry, biology, or maths, or any combo of chemistry, biology, maths, all 3, in fact, and you can use that coupon code to access the course for a month for absolutely nothing, okay? But you still have to put in your card details because it is a subscription. So if you signed up today using that coupon, you use it for a whole month, but on the 2nd of November, so in a month's time, it will go in and take that subscription price from you, okay, from your account, and then you've got another month, okay? So you only get your first month free. You know what? We're really confident you'll love the course, all right? But if you do feel like you want to, you don't want to carry on, and you don't want to carry on, you don't want to pay for it, then as long as you unsubscribe or cancel your subscription in that first month, you won't pay a penny. Okay, so yeah, we're really confident. We want people to go in and have a look at our course because, you know, we're not the type of tutors or type of service that go out shouting it about, blitzing your Facebook and Insta and every web page you go on with adverts. All right, we're confident in our product. Okay, and when you find us, we want you to have a look at it, and then when you have a look at it, we are so confident you love it, then, you know, we reckon you'll stay. We you know, because we want to help you. We've helped thousands of students get the grades they need to get to university. We've had students go from U's. I had a student go from a U to a B last year in chemistry. We've helped people get their A stars and get into medicine. So yeah, that's what we do. That's what we're about. We're about helping you. It's a personal service. We get to know the people in our live classes as well, you know, so it's not just, you know, oh yeah, pay for it and you just get access to some videos. We're all over it. Okay, we're always here to help. So is it possible to take chemistry in a year? You got to be dedicated. You got to be really dedicated. I would say it is possible. How possible it is to get the top grade in it in a year, I don't know. But if you're going to do it in a year, do the year 1 stuff first and then the year 2, because the year 1 stuff gets built on in year 2. So that's really, really important. I.e., I've not taken the A's. I'm not sure what you mean by that, Kim. There is a problem with the website. It only prints 4 pages out of 9 for the PDF in year 12. Okay. So yeah, thanks for that, Rich. What happens after you register? Yeah, as Rich is saying, rightly so, we check your email address to make sure it matches up with a TT subscription. Once we've done that, then we send you the link so you can access the live class when it goes live at 6 o'clock. Okay. So in terms of the PDFs, okay, because what we're doing is we're covering AQA, OCR, and EdXL. Those questions I've taken from all the different exam boards, okay, even WJEC, some of them, I'll be honest with you, I'll hold my hands up, and the Welsh board. But the thing is, what we do is obviously we focus on the major aspects of those topics, which are covered in every exam board. There are going to be some questions, of course, that, you know, the little specifics, little differences between the exam boards, and we talk about those in the live class as and when they crop up. But all of the questions, I guarantee you, are relevant to your exam board. They are cross-exam board questions. I've curated those for you guys so that they are 100% relevant for you guys, okay? Oh, Kim, so you haven't taken AS, right? So if you haven't taken AS, like I said, make sure you do the AS content first, okay, and do some exam practice using all the AS papers, and then go on to the A-level content, because like I said, you do electronic structure in year AS, and then that gets ramped up in year 2 when you do transition metals and stuff like that. You do redox in AS, that gets ramped up. You do acids in AS, that gets ramped up. So do all that year 1 stuff first, and then your year 2, okay? Stealthy Wolf, is it a good idea to do heaps of past papers and repeat the past papers until you get the grade you want constantly? Yeah, that is actually part of our TT method, all right? So our TT method is the case of, right, people think when you do a past paper from start to finish. Now, this only really comes into play towards the end of the year, okay, when you've covered all your topics. Do a whole past paper, a paper 1. All right. Now, once you've done that paper and you've marked it, you think, oh, it's dead to me now. I've done that one. There's no point doing it again. Not true. So it's really important to do a whole past paper, okay, in timed exam conditions, really important, and then mark it and analyze it. Okay. Now, when I say analyze it, you need to look at the questions that you bombed on. Okay. Look at the questions you did really well on and make a little note. That's great, because you know what? I'm all over redox. I smashed that. I don't need to do so much work on it. But maybe in terms of organic chemistry, you lost a lot of marks in organic chemistry. What you need to do then is go away and look at those topics, use the course videos, look at some example questions that we've got on the website, and just, you know, top up your chemistry knowledge on that. And make sure you revise it, because it helps you target specific areas to revise, okay? Once you've done that, okay, go back and do the same paper, time conditions, the whole paper again. And I guarantee you, some questions, it'll surprise you, some questions you got 4 marks on last time, you might not get 4 marks on this time, but hopefully you will have improved in the areas that you needed to, okay? So what you need to do is, yeah, repeat it as many times as you need to. I'd say up to 3 times is probably the maximum. Give yourself a bit of time in between them, even a week, okay? Go back and do it again, and then remark it and reanalyze it. Are there only any other areas that you now need to focus on? And just do it that way. And you know, we haven't got many new spec papers to look at because it's a fairly new spec, but okay, you're going to have lots and lots of exam practice in that respect, okay? You're going to get exam fit, and you're going to get used to exactly what words and calculations you're expected to use in your answers, all right? So what if you just remember the paper? Well, you know what, Raseb, you probably will remember a few of the questions in the paper, but you're still going to have to go through the motions of the calculations. You're still going to have to make sure you use the right key terms. You're going to improve on your answers from the last time. Hopefully, maybe your answer in a level of response question, you know, those extended response questions, maybe it was a bit disjointed last time. Improve it for the second time round. There is so much more benefit in doing those papers again than you realize. You know, it's the TT method. Hundreds and thousands actually of students used it last year along with us when we released our revision kit, and it works. I promise you it works. You will remember some of the questions, but then examiners, I wouldn't say they're lazy, but surely by now, those of you in year 13 must have realized they use very similar questions on the same topics, okay? There's only so many ways they can ask certain questions on certain topics. So you're going to get exam fit that way. And wouldn't it be nice to walk into your exam in June, look at question 3, go, oh, that's loads like that question I did on that paper, you know, 3 times, okay? It's almost exactly the same. I remember what the mark scheme said for that, okay? So there's so many benefits for that, okay? It won't download it as a PDF. He wants to download as a HTML. Okay. Okay, so you can right click on the PDF hyperlink from the registration page and download the file from there. Oh yeah, I can show you how to do that. Let's do that very quickly, and then I'm going to have to go, guys. I want to get prepped for my web class. So I'm just going to share screen again, and I'll show you how to do that. Okay, so hopefully all you guys are seeing this now. Are you seeing it? Yeah. Okay, so what you can do, PDF, right click, open a new tab, open a new window. Okay, copy link address, copy. Oh, print, does that do it? What's that going to print? that's not going to print it. Okay. I'm not sure why the right click isn't working there. So if I actually just open that one for year 12, yeah, there were definitely 9 pages. When I right click, print. I'm just looking at the preview now. Yeah, it doesn't seem to be giving me all the pages. That is very, very weird. Well, what I'll do, guys, if you're coming to the web class, obviously there's something very weird going on here. I will see if I can't give you that link somehow else. Or in fact, what I might do is I might email it to you guys before the web class starts, okay? So I think that's what I'm probably going to do. Yeah, it's a bit of a weird one. That's never happened before. So yeah, what I'll do is on this occasion, I will grab all the email addresses of everyone that's registered and send and email it. Okay. Or indeed, as Rich is saying there, I'll see if I can find a way of sharing it in the live class. So one way or the other, we'll make sure you get all that PDF to you. But you know what? You're still going to have it on screen in front of you, aren't you? Okay, so at the very worst, you can get it up on screen. You don't necessarily need to print it out. That's ideal, so you can have a go at the questions proper. But yeah, we'll figure that out, guys. Okay, technology, eh? What can you do? So I'm going to go. I'm going to wet my whistle and get prepped ready for that live class. So hopefully I will see you guys at 6 o'clock. I'm going to try and find a time in the week where I can just come online and help you guys out and answer any of your questions on chemistry. We'll see what we can do there. Yeah, I'll see you in the live class at 6 o'clock. If not, if you're year 13 and you only want to come to the year 13 where we're doing lattice enthalpy, then I will see you at 7 o'clock. Okay, so atomic structure and electronic structure, a little bit of mass spec maybe for year 1 or year 12. And then, of course, lattice enthalpy for year 13. Okay, so I will see you at 6. If not, and you're not a subscriber, get subscribed. You can subscribe for absolutely nothing, guys, right now. So, you can access all the live classes and all the benefits of being a TT subscriber. But like I said, your first month is absolutely free. Try TT free, all one word, all caps, TRYTTFREE. And yeah, get involved. You've got absolutely nothing to lose. Go in, have a look around, get involved. Okay, put some comments in, ask us some questions. We're there to help. All right, so I'll see you very soon. Take it easy.